It all began with a mystery so small that no one could see it. A mystery hidden inside light itself. For centuries, the greatest scientists believed they understood how the universe worked. Isaac Newton had explained gravity. James Clerk Maxwell had revealed the nature of electricity and magnetism. Steam engines powered cities, factories transformed nations, and technology was advancing faster than ever before. By the end of the 19th century, many experts confidently declared that physics was nearly complete. They believed only a few tiny details remained to be solved. But those tiny details would soon shatter everything. Deep inside laboratories, strange experiments refused to obey the laws of classical physics. Light behaved in impossible ways. Heat radiated from glowing objects in patterns that no equation could explain. The closer scientists looked, the more confusing nature became. Then, one quiet German professor dared to make an assumption that even he found unbelievable. That single idea would become the birth of quantum physics. It would forever change science. It would lead to lasers, computers, smartphones, MRI scanners, quantum computing, satellites, and technologies that power the modern world. And it all started with a man who never wanted fame. His name was Max Planck. Born on April 23, 1858, in the beautiful city of Kiel, Germany, Max Karl Ernst Ludwig Planck entered a family that valued knowledge above all else. His father was a respected professor of law, while several relatives were judges, scholars, and theologians. Education was woven into everyday life, and thoughtful discussion filled the family home. As a child, Max was quiet, polite, and remarkably curious. He was not the loudest student in the classroom, nor the one seeking attention. Instead, he preferred observing the world carefully, asking thoughtful questions, and searching patiently for answers. When his family moved to Munich, young Max attended the prestigious Maximilians Gymnasium. There, he quickly earned a reputation for his intelligence, discipline, and extraordinary memory. Yet what fascinated him most was not history or literature. It was nature. He wondered why the stars moved across the night sky with such perfect order. He marveled at the changing seasons, the colors of sunlight, and the invisible forces shaping the universe. Every phenomenon seemed to whisper that there were hidden rules waiting to be discovered. One of his teachers recognized this quiet brilliance. His mathematics and physics instructor encouraged students not merely to memorize formulas but to understand the deep principles behind them. Those lessons ignited something inside Max that would never fade. Outside the classroom, another passion filled his life. Music. Planck became an exceptionally talented pianist and could play difficult compositions by Mozart, Beethoven, and Schubert with remarkable skill. He even composed original music and briefly considered becoming a professional musician. For a time, he stood at a crossroads. Should he dedicate his life to music? Or should he pursue science? Both offered beauty. Both revealed patterns hidden beneath the surface. After much reflection, Max realized that physics possessed a kind of harmony all its own. The universe seemed like an enormous symphony, with every law of nature contributing to a perfect composition. He wanted to understand the score. At 17, Planck enrolled at the University of Munich to study physics. Before making his decision, he sought advice from one of his professors. The professor smiled kindly but offered unexpected guidance. "Young man," he said, "there is almost nothing left to discover in physics. The major breakthroughs have already been made. All that remains is refining existing knowledge." Many students would have chosen another field after hearing those words. Not Max. He replied calmly that he had no desire to discover something new merely for fame. He simply wanted to understand how nature truly worked. That quiet determination would soon change history. During his university years, Planck immersed himself in mathematics, thermodynamics, and theoretical physics. While many students rushed through their assignments, he studied every concept with extraordinary patience. He believed that every equation told a story. Every formula revealed another piece of the universe's hidden design. Later, he continued his education at the University of Berlin, where he learned from some of Germany's greatest scientists, including Hermann von Helmholtz and Gustav Kirchhoff. Although these famous professors rarely inspired him through their lectures, Planck never complained. Instead, he spent countless hours teaching himself from books, conducting independent studies, and developing his own understanding. He trusted careful thinking more than dramatic inspiration. After earning his doctorate, Planck began teaching at the University of Kiel before eventually accepting a prestigious position at the University of Berlin. His lectures became known for their remarkable clarity. He spoke softly, never theatrically. Yet every sentence reflected careful thought and deep understanding. Students respected him because he never exaggerated. He allowed the evidence to speak for itself. By the 1890s, Planck had become one of Germany's leading experts on thermodynamics, the science of heat and energy. Factories depended upon it. Steam engines relied upon it. Entire industries were built upon its principles. It seemed like one of the most complete areas of physics. Then one stubborn problem refused to disappear. Scientists were studying objects heated until they glowed, pieces of iron, electric filaments, and furnaces burning at incredibly high temperatures. As these objects became hotter, they changed color. First red, then orange, then brilliant white. The pattern appeared simple. Yet no mathematical equation could fully explain exactly how they emitted light. Every calculation based on classical physics produced impossible results. Some equations predicted that heated objects should release an infinite amount of ultraviolet energy. If that were true, even a fireplace would produce unlimited radiation. Clearly, nature disagreed. Physicists called this contradiction the ultraviolet catastrophe. The name sounded dramatic because the problem truly was. It suggested that one of the greatest foundations of physics might be fundamentally incomplete. Across Europe, brilliant scientists attacked the problem using every known method. Each attempt failed. The equations refused to match reality. Planck became increasingly fascinated. What began as an ordinary research project slowly turned into an obsession. Day after day, he filled notebooks with calculations. Night after night, he searched for patterns no one else could see. Sometimes he remained at his desk until sunrise. Friends worried he worked too hard. But Planck couldn't stop. Somewhere inside the mathematics, he believed, nature was trying to reveal a deeper truth. As the 19th century drew to a close, pressure mounted. Scientists expected answers. Universities demanded progress. Yet every calculation ended in frustration. Then, on one cold evening in late 1900, while staring at pages filled with equations, Max Planck made a mathematical assumption so strange that he could hardly believe it himself. It contradicted everything physicists had accepted for centuries. He almost dismissed it. But when he completed the calculations, something extraordinary happened. For the very first time, every equation matched reality perfectly. The impossible mystery had suddenly become solvable. Without realizing it, the quiet professor from Germany had just opened the door to an entirely new universe. And nothing in science would ever be the same again. Max Planck sat in complete silence, staring at the pages before him. The equations were correct. He checked them once. Then twice. Then again and again, hoping to find a mistake. But there wasn't one. For years, the problem of black-body radiation had frustrated the greatest physicists in Europe. Every classical equation had failed. Every respected theory had reached a dead end. Yet this strange new assumption worked perfectly. Still, Planck could hardly believe what his mathematics was telling him. To make the equations fit reality, he had assumed something that seemed almost impossible. He proposed that energy was not emitted continuously. Instead, it was released in tiny, indivisible packets. Small bundles of energy. Tiny quanta. It was a purely mathematical trick, or so he believed. Planck himself did not think nature actually behaved this way. He simply wanted an equation that matched the experimental data. Yet the universe had other plans. On December 14, 1900, Planck presented his findings to the German Physical Society in Berlin. The room was filled with respected scientists. No one applauded dramatically. There were no newspaper headlines waiting outside. In fact, most people hardly realized they had just witnessed one of the greatest moments in scientific history. Planck calmly explained that the energy emitted by atoms could only exist in fixed amounts. He even introduced a new fundamental constant into physics, a tiny number that would later become famous around the world. Today, every physics student knows it as Planck's constant, one of the fundamental constants of nature. Without it, modern quantum mechanics could not exist. At first, few scientists understood the true significance of his work. Some viewed it as nothing more than a useful mathematical shortcut. Others politely ignored it. Even Planck remained cautious. He hoped that someday classical physics would explain the results without requiring such a radical idea. But the evidence continued to grow. Year after year, experiments kept confirming his equations. Then, in 1905, a young patent clerk in Switzerland read Planck's paper with enormous excitement. His name was Albert Einstein. Einstein believed Planck's idea was not merely mathematics. He believed it described reality itself. Using the concept of energy quanta, Einstein explained another puzzling phenomenon called the photoelectric effect. Light, he argued, sometimes behaved like tiny packets of energy. Today, we call those packets photons. Many scientists were shocked. Light had always been understood as a wave. How could it also behave like particles? The idea sounded absurd. Yet experiment after experiment supported Einstein's conclusions. Planck watched with growing amazement. The strange assumption he had introduced reluctantly was beginning to reshape the entire foundation of physics. Soon, other brilliant scientists joined the revolution. Niels Bohr used quantum ideas to explain the structure of the atom. Louis de Broglie proposed that matter itself could behave like waves. Werner Heisenberg developed the uncertainty principle. Erwin Schrödinger described particles using wave equations. Paul Dirac united quantum mechanics with Einstein's theory of relativity. One extraordinary breakthrough followed another. The tiny mathematical quanta introduced by Planck had become the language of the microscopic universe. Physics was being rewritten. Although the world increasingly recognized Planck as the father of this new scientific revolution, he remained remarkably humble. He disliked exaggerated praise. He preferred quiet conversations, careful reasoning, and respectful debate. His colleagues admired not only his intelligence but also his kindness. Unlike many famous scholars, Planck welcomed young researchers into his office with patience and encouragement. He believed that science advanced through cooperation rather than competition. His calm personality helped create one of the greatest scientific communities in history. Berlin became the center of theoretical physics. Scientists from across Europe traveled there to exchange ideas. Hallways echoed with discussions about atoms, light, radiation, and the mysterious quantum world. Planck often found himself surrounded by some of the brightest minds on Earth. Einstein, Niels Bohr, Arnold Sommerfeld, Walther Nernst, Max von Laue. Their conversations sometimes continued late into the evening. No one claimed to have all the answers. Every new discovery seemed to reveal even deeper mysteries. The more they learned, the stranger nature became. Particles appeared to exist in multiple possibilities. Light behaved both as a wave and a particle. Cause and effect no longer seemed as straightforward as classical physics had promised. Many older scientists resisted these ideas. They preferred the comforting certainty of Newton's universe. Planck understood their hesitation. He, too, had grown up believing that nature followed smooth, continuous laws. Accepting quantum theory required abandoning centuries of intuition. It was not easy. Yet truth mattered more than comfort. If experiments consistently supported the new theory, scientists had a responsibility to follow the evidence wherever it led. That commitment to honesty became one of Planck's greatest strengths. In 1918, nearly 2 decades after introducing the quantum hypothesis, Max Planck received the Nobel Prize in Physics. The award recognized his revolutionary discovery that had opened an entirely new chapter in science. By then, the world finally understood the importance of his work. The quiet professor who had once doubted his own theory had become one of history's greatest physicists. But despite international fame, Planck never allowed success to change his character. He still walked modestly through the university halls. He still listened more than he spoke. He still approached every scientific question with humility. To him, the universe remained far greater than any individual scientist. Every discovery simply revealed another doorway waiting to be opened. Outside the laboratory, however, Europe was changing. The optimism of scientific progress was slowly giving way to political unrest. Nations that had once celebrated cooperation were becoming divided by fear and conflict. The First World War shook Europe to its foundations. Millions of lives were lost. Families were torn apart. Even scientists who had once worked together found themselves separated by national borders and bitter hostilities. For Planck, these years brought profound sadness. He believed science belonged to all humanity. Knowledge should unite people, not divide them. Yet the greatest trials of his life were still ahead. In the years to come, he would face heartbreaking personal losses, witness the rise of one of history's darkest regimes, and endure tragedies no scientific achievement could ever erase. Through it all, he would remain guided by the same quiet principle that had shaped his entire life. Seek the truth. No matter how difficult the journey. No matter how high the cost. And that unwavering commitment would define not only his scientific legacy but his humanity. As the years passed, Max Planck watched the world transform in ways he could never have imagined. The tiny packets of energy he had introduced almost by accident were no longer just strange mathematical symbols. Across Europe and America, laboratories buzzed with excitement as physicists uncovered astonishing new secrets of the quantum world. Every month seemed to bring another discovery that challenged everything people thought they knew about reality. Yet while science was entering one of its greatest golden ages, the world outside the laboratory was descending into darkness. Germany struggled after the First World War. Economic hardship spread through the country. Inflation destroyed savings, unemployment rose, and political extremism gained strength. Hope slowly gave way to fear. Max Planck continued teaching, writing, and encouraging young scientists, believing that knowledge and reason could help humanity build a better future. But history had different plans. In 1933, Adolf Hitler came to power. Almost immediately, Germany began changing in terrifying ways. Universities lost their freedom. Jewish professors were dismissed. Scientists fled the country. Books were burned. Fear replaced open discussion. Many of Planck's closest colleagues, including Albert Einstein, left Germany to escape persecution. Watching brilliant minds forced into exile broke his heart. Planck believed that science belonged to all humanity. It had no nationality, no race, and no political party. Knowledge should unite people, not divide them. Despite the growing danger, Planck chose to remain in Germany. He hoped that by staying, he could protect German science and preserve what remained of its academic traditions. It was an almost impossible task. One day, Planck personally met with Adolf Hitler. With quiet courage, the elderly scientist pleaded for Jewish researchers to be treated fairly and allowed to continue their work. Hitler responded with anger. The meeting ended in failure. Planck left knowing that reason alone could not overcome hatred. Still, he refused to abandon his principles. He continued helping colleagues whenever he could, offering encouragement and support during one of history's darkest periods. Then tragedy struck even closer to home. His beloved wife, Marga, passed away after years of companionship. The loss left a deep emptiness in his heart. Yet even greater sorrow was still to come. During the Second World War, Planck's youngest son, Erwin, became involved in a resistance movement determined to stop Hitler's dictatorship. Following the failed assassination attempt against Hitler on July 20, 1944, Erwin was arrested by the Nazi government. For months, Max Planck desperately appealed for mercy. He wrote letters. He met officials. He begged for his son's life. Nothing changed. In January 1945, Erwin Planck was executed. The grief was almost unbearable. The elderly scientist who had spent his life uncovering the elegant laws of nature now faced a pain that no equation could ever explain. Friends feared he would never recover. Yet somehow, despite unimaginable heartbreak, Max Planck refused to surrender to bitterness. He continued believing that truth, knowledge, and human dignity were stronger than hatred. When the Second World War finally ended, Germany lay in ruins. Cities had been destroyed. Universities had been damaged. Entire generations had been lost. Planck, now in his late 80s, looked upon a nation he scarcely recognized. Even so, he remained hopeful. He believed rebuilding science was essential for rebuilding civilization itself. Young researchers once again sought his guidance. To them, Planck was more than a Nobel Prize winner. He represented integrity, humility, perseverance. He reminded them that science was never about fame or personal glory. Its true purpose was to understand nature and improve the lives of others. On October 4, 1947, Max Planck passed away at the age of 89. His quiet voice was gone. But his ideas had only begun their journey. As the decades passed, quantum physics transformed the world beyond anything even Planck could have imagined. The strange quanta he had introduced in 1900 became the foundation of nearly every modern technology. Lasers revolutionized medicine and communication. Semiconductors gave birth to computers. Microchips made smartphones possible. Solar panels converted sunlight into clean energy. MRI scanners allowed doctors to see inside the human body without surgery. Fiber optic networks carried information across oceans in the blink of an eye. GPS satellites guided airplanes, ships, and millions of travelers every day. Quantum mechanics also opened entirely new frontiers. Scientists built particle accelerators to explore the smallest building blocks of matter. Space telescopes peered billions of light-years into the universe. Quantum computers promised to solve problems once thought impossible. Every one of these achievements traces its roots back to the quiet professor who dared to question how light behaves. Today, his name lives on everywhere. Planck's constant remains one of the most fundamental numbers in physics. The Max Planck Society, one of the world's leading scientific organizations, continues supporting groundbreaking research across dozens of disciplines. Students in every corner of the world still learn about his revolutionary discovery. But perhaps Max Planck's greatest legacy cannot be measured by equations alone. He taught humanity something far more important. That even when everyone believes a problem has already been solved, curiosity can reveal an entirely new universe. He showed that genuine greatness often comes quietly. Without arrogance. Without seeking attention. Without demanding recognition. He once said, "Science advances one funeral at a time." It was a thoughtful reminder that new ideas often face resistance not because they are wrong, but because accepting them requires letting go of old beliefs. Planck understood that progress demands patience. Truth is not determined by popularity. It is discovered through careful observation, honest thinking, and the courage to question what everyone else assumes is certain. Imagine the modern world without his discovery. No smartphones. No laptops. No lasers. No MRI machines. No satellite communication. No quantum research. No modern electronics as we know them. The invisible world he uncovered powers nearly every aspect of daily life. And it all began with one scientist quietly searching for the answer to a single question about light. The next time you unlock your phone, use a computer, receive medical treatment, navigate with GPS, or simply switch on a light, remember Max Planck, the humble physicist who believed the universe still held secrets waiting to be discovered. His story reminds us that history is not always changed by the loudest voices or the most powerful leaders. Sometimes it is changed by a patient thinker sitting alone at a desk, refusing to give up on a question no one else could answer. Because every great revolution begins with a single idea. Every impossible mystery begins with a single question. And every extraordinary future begins with someone brave enough to imagine that the universe may work differently than anyone has ever believed. Max Planck did exactly that. By unlocking the hidden language of energy, he opened the door to the quantum age. More than a century later, humanity is still walking through that door, discovering new wonders, exploring new frontiers, and proving that the smallest ideas can create the greatest revolutions. The end.